All right, so officially, if you're watching the video, the test is going to be 1-1 through 1-3. It's going to be moved to Monday the 13th. Now, if you're ever absent, and I saw a couple of people that were absent yesterday, or they emailed me, or like, what did I miss, right? What did I miss? Well, I record every day's lesson, every single day, and I dump it into the shared folder. So I put that link on Canvas. If you go to the Precal folder from this year, this is 2020 to 2021, right? What year is it, Brady? It's already 2021. Well, look in the 2021 to 2022 folder, and then go to chapter 1 and search by date, right? You can search by date or click your files to arrange by date, and it should jump to the top, and you're like, boom, that's recorded on the day I was absent. And you can play it on your iPad, and you're like, he's like talking to me, right? He's talking to me. I'm watching it. I'm here at the Starbucks, and I'm watching math videos, you know? Dang, I'm getting better already. I think I'll be back in class tomorrow. All right, so just check search by date, because I'll talk about what we're doing that day as well. All right, so rationalize and simplify. You got 4 plus the square root of 7 over 42. Step 1 is to simplify. 4 plus the square root of 7 over 42. It's already simplified. 7 is simplified. It's a prime number. So how do we simplify when we have something like this with 2 terms? How do we rationalize, I should say, sorry. Can I multiply by the square root of 7 over 7? Will that work? Well, it's not illegal to multiply by the square root of 7 over 7. It's not illegal, because that's equal to 1. And multiplying by 1 is okay, bueno. But look what happens. If you distributed the square root of 7, you're going to get 4 square root of 7 plus 7 in the top. We're trying to get rid of the radical from the top. Does that do the trick? Nope. All it did is it moved the radical from one term to the other term. So that is not illegal, but it's not helpful as well. Okay? It's not helpful as well. Well, we don't call it the opposite. We call it the what?
Oh, conjugate.
The conjugate. What's that? The reciprocal is when you flip something, like 5 and 1/5. Okay? And then the opposite would be like 5 and -5. Those are words that maybe everyone's used interchangeably. I'm glad you asked that. A reciprocal is a flip, okay? So 5 and 1/5. An opposite is a negative, so 5 and -5. Now, some people use the word inverse for reciprocal. That's not true either. An inverse operation undoes the work of another operation, like multiplying and dividing undo each other. Those are inverse operations. Addition and subtraction undo each other. Those are inverse operations, okay? Square rooting something and squaring it, those are inverse operations, okay? So we got reciprocal, opposite, inverse, and now we have conjugates. What makes 3 plus the square root of 2 the conjugate of 3 minus the square root of 2? The only difference is the plus sign between the 2 terms, right? If we start with 3 minus the square root of 2, that becomes 3 plus the square root of 2. If this had been the square root of 2 minus 3, if those had been flipped, then the conjugate would be the square root of 2 plus 3. All we do, the only thing we do is we change the sign between the 2 terms. That's it, okay? And that gives us conjugates. And when you multiply 2 conjugates together, that gives you a what? Like x minus 2 times x plus 2. You multiply those out, you get x squared minus 4. That gives you a difference of squares. Yes, okay? Now, remember, when you do multiply by the conjugate, don't do some Chris Angel stuff, right? Don't let them be levitating. Make sure you put a division bar between them like that. All right? So now it's equal to 1. All right, so let's go ahead and do this. We're going to multiply this by 4 minus the square root of 7 all over 4 minus the square root of 7. Now, let's go ahead and multiply out the numerator first. I'm going to put parentheses here because it is foiling. First, outer, inner, last. But because they are conjugates, the inner and the outer do what? Cancel out. That's the right terminology. Things cancel out to give you 0. Muy bien. So we're going to get what in the top? We're going to get 4 times 4, that's 16. On the inside, we get 4 root 7. On the outside, we get minus 4 root 7. Those are opposites. They cancel to give us the identity element of addition, which is 0. And so now we just have the last. Square root of 7 times negative square root of 7 is negative 7. And then the bottom, we have 42 times 4 minus the square root of 7. You don't want to distribute the 42, not on this line. You do want to distribute the top because by design, 2 conjugates will get rid of the radical. And it worked, right? See, we don't have a radical on the top anymore. But you want to leave the bottom factored because we might need to simplify on the back end. And remember, we can only divide out common whats? Factors, right? And so let's leave the 42 factored. All right, moving straight down. Get out of the way, pre-cal matters. 16 minus 7. ¿Cómo se dice? 9? Yeah. 9. 42 times 4 minus root 7. We're still going to leave it factored. Now, I'm not going to work down to example 3, so I'm going to start a new column. 9 40-seconds. Is there anything in there that's common?
No, if it was 45ths, then yeah.
45ths would work because 9 45ths, 9 goes into 45.
Yeah.
So 9 would be a factor of 45. But do 9 and 42 have a common factor other than 1? That is, are 9 and 42 co-prime? Rhymes with go, starts with N. Very good. No. Very good. 3. Y'all know how to determine if a number is divisible by 3 very quickly? Did y'all learn that at some point along the way? Yes, you add the digits. We call that the digital index of a number. The digital index of a number is the single digit number that you get by repeatedly adding their digits together. If it's a multiple digit number and you roll over like to 12, then you add those together. 2 plus 1 is 3, okay? So what's the digital index of 42? It would be 4 plus 2, which is 6, okay? If the digital index of a number is divisible by 3, then so is that number. So because 6 is divisible by 3, so is 42. Now, 42 is one of those numbers that you may know has 3 as a factor, but that's a useful tip for very large numbers. It's a divisibility trick. So you don't actually have to show me that 9 is 3 times 3 and 42 is 3 times who? You can just divide it out, right? So 9 divided by 3 is 3. And what's 42 divided by 3? 14. Muy bien, bien. If you got to go out to the side and do retro long division, that's fine. 4 minus root 7. And at this point, you could either stop if you wanted to. I kind of like that version. Or if you feel like it, now would be the time to distribute. 56 minus 14 root 7. These are both I would consider equally simplified. It's just a matter of what we plan on doing with the expression after we rationalize it. But the task was met, right? We started with the radical in the numerator. We rationalized it, and now the radical is in the denominator. Okay? Excellent. Sweet. Y'all got that? Rationalized? Okay. And again, we had to multiply by the conjugate because we started with 2 terms. If it's just a single term, then we multiply by the power of x, remember, that makes the exponent 1. That makes it complete because that gets rid of the radical. All right. So that brings us to example 3. How much time do we have? 40, 60, 24 minutes? Okay. Yeah. I'm a real bad manager of time this year because I'm still in like hour-and-a-half mode, you know. And the bell rings and I'm like mid-sentence, you know. You like block schedule? I would recommend block schedule if we met every period all day. So like instead of getting out at 4 o'clock, we go like to 8 o'clock every day. But every class is an hour-and-a-half. Is that what you're saying? Because I would be on board for that. Just think of, that's like double the learning. So yes. All right. I'll let that I'll let the school board know that that's what we're on board for, and it's Cole's idea. And yeah, I mean, give credit where credit is due, right? Hey, how's Verlander this year? Is he even playing or did he retire? He's injured, right? He did have Tommy John surgery.
Yeah.
So he's not in the rotation yet? No. So he's kind of retired time for this season. Okay. All right. How's that Cole guy doing that was the trader that went to the Yankees? Is he still pitching well? No. Okay. Yeah, he should have stayed with the Stros, right? Karma, right? Karma. See what happens when you betray your homies? We're homies, right? We're math homies. We stick together. All right. Example 3a. It says to simplify the following rational expression. A rational expression is a ratio. See the first 5 letters in the word rational? Ratio. It's a ratio of 2 polynomials. Now, instead of using boring old x here, I used y. So to simplify, what does this mean? Well, we have expanded expressions in the numerator and denominator of both factors, okay? If we're going to simplify, we would like it to be what? Factored. Because we can divide out common factors, we cannot divide out common terms. We cannot. Okay? So if you like look at this, you're like, ooh, ooh, ooh. I get that, right? It's math, you're getting excited. But if you're saying, ooh, 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 look, 4y squared and 2y squared, that gives me a 2, and then these are gone, right? I mean, you're like worse than a toddler. You're doing some mathematical destruction there, okay? Now, if you're trying to be funny, then ha-ha, that's hilarious. I get that. That's a good math joke. You know why? Because that doesn't work. That doesn't work. Because that's trying to divide out common what? Terms. See, that doesn't even sound as good. We can only divide out common factors. That's right, factors. So that's what we're going to do, okay? Ha-ha, we get it. We're going to go to the next line working straight down. And the first thing we're going to do, boom, is change the division to multiplication, okay? That's what we do. So y'all might have learned stay, change, flip, right? Stay, change, flip. I taught my dog that this summer. He's really good at it. Okay, stay, stay, stay. Good girl. Excellent girl. Change, change. Okay, be a different person. All right, good. And now flip. And that's really the highlight of that trick. Stay, change, change. Okay, good. Flip. Have y'all heard stay, change, flip as like a math thing, not as a dog trick? Yeah, yeah. I mean, you tell a dog to change, and they just look at you, those puppy dog eyes, like, I didn't mean to eat up the furniture or poop in the house, right? But those behaviors we need to stop, Ruby, okay? She's a boxer. She's really happy. So she's really good at the flip part, okay? Not so much the stay and change. Stay, change, flip. Stay, change, flip. Stay, change, flip. Stay, change, flip. Yeah. Now, we could do that as a separate activity and just write it like that, but here's what I'm going to do. It's a lot of writing. So as I do stay, change, flip, I'm also going to start with the factoring process, okay? It's an optional thing. If you just want to like tidy it up, stay, change, flip, that's good. But this is the one that stays. So as I work straight down, I'm going to start factoring it. 4y squared minus 9 is a special product. It's a difference of 2 perfect squares. So it factors into the product of 2 what? Conjugates. Conjugates. See, if I say it enough, it's going to be like, yeah, okay, he has a boxer named Ruby. This is going to be the product of 2 binomials. The square root of the first, square root of the last. The square root of 4y squared is 2y. The square root of the last is 3. So that's how you get your 2 terms. One of them's plus, one of them's minus. It doesn't really matter which one. I apologize if my method of teaching kind of throws you off a little bit. I did have a student this year tell me that she liked the way I taught, but it was distracting to her. And it's wise to know that. She didn't like all the abrupt breaks and all the jokes. It broke her concentration. And she told me politely, and she moved to a different class with a teacher that teaches just more directly. So I get it. I get it. I've kind of like wondered about that my whole teaching career. So I apologize if it bothers you. But again, there's a method to my madness, right? The more breaks I put in, starting and stop, students tend to remember the beginning and the end, right? It's a psychological phenomenon, right? Plus,
Psychological warfare on us.
maybe warfare, right? Mathematical warfare. Weapons of math destruction. Ooh. All over what? At least we're not in Afghanistan right now, right? Those people are trying to go to school and they're not allowed to. They're not allowed to. I think it's going to win the Pulitzer Prize, the picture of that guy teaching class out in an open field while the Taliban is mining minerals in the background. This is Corpy. Oh, she is, yes. With stuff, will do. Uh-huh. Okay, back office with stuff. Anyway, has anyone else seen that picture? Maybe we'll do it tomorrow as a warm-up. It's a phenomenal picture. So we take a lot of stuff for granted in America, that we can just get up and safely commute to school, and you know, we show up, safe environment, have a good time, learn a little math, learn a little sisu along the way, right? Treating others with kindness and respect. There you go. Shaken, not stirred. All right, factoring the bottom one. Is there a common factor? Simone, I'm recording right now, so when you watch this video, you'll be hearing your name. Okay. No, there's nothing in common there. So we're going to have to factor it by a snowflake method off to the side, split the middle term method off to the side, whatever you want. Now, here's what I would do. Again, I mentioned about how I learned this, right, with the fruit flies and the heat. 2y squared. 2 is prime. There's only one way you can factor 2y squared. It's got to be a 2y and a 1y, or a 1y and a 2y. So get that part out of the way. It takes a lot of the guesswork out of it. Now, factors of 18, there's few of them, right? 1 and 18, 2 and 9, 36 and a half. No, we don't use those. We don't go with fractions. So let's try them out. What do you want to try? You want to try the 18-1 combo? We're trying to get a 9.
36.
36 and a half?
3 and 6.
Oh, 3 and 6. Oh, yeah, 9 and 2, I thought, but 3 and 6. Let's try 3 and 6. So let's try a 3 here and a 6 here. If it doesn't work, we'll flip it around to the 6-3 combo. We're trying to get a 9 on the inside. This gives us a 3 on the inside and a 12 out there. Okay? 12 minus 3, is that 9? It is. Nice. Nice. So we know we subtract it and get 9. So dang, we got it on the first try. If that didn't work, I would flip the 3 and 6 around and try the 6-3 combo. If that didn't work, I would try the 2-9 and the 9-2. I probably wouldn't try the 18-1 because I would have found the right answer by then. Okay? Oh, absolutely. Yes. Yes. Don't even take the hall pass. Just go. Okay? All right. Aiden, hope you're watching the video, and I hope you're okay at this point when you listen to it. Okay. All right. Now we just need to work on the SIGN sign. We know that they have to be opposite signs because 18 is negative. Yes, yes? Negative product. But the 9 is positive. So the larger of the two products, inside, outside, has to be positive. I have an inside product of 3 and an outside product of 12. So the 12 has to be positive. In order for the 12 to be positive, this has to be a plus sign here and a minus sign there. Okay? And now you can quickly mentally try it again. On the outside, you get 12 minus 3, that's 9. Boom. First is 2y squared, last is negative 18. We did it, we did it, we did it, yeah. Now, the way these problems end up working out, you can kind of also take a cue in the factoring from other places in the problem, right? Por ejemplo, look at the numerator. There's a factor of 2y minus 3 and a 2y plus 3. Look at one of the factors that we ended up in the denominator, 2y minus 3. So these problems are kind of designed so that things will divide out. So if you're struggling, you might be, oh, I think it's going to be a 2y and a 3 combo. So 3 times what is 18? Oh, it's got to be a 6. Does that make sense? It's strategizing, and it transcends the math classroom because you're really solving a problem in a situation where you have a little bit of knowledge and you have a lot of resources, and you got to persist and try and get things done, right? You take clues from things around you. Why are the birds chirping? Why are the locusts flying? Why are the cows all facing the same way in the field? Oh, there's a tornado coming. Yeah. I don't know if that's what that means. But have you ever driven by a field full of cows and they're all grazing and facing the same way? Yes. Look for it next time. That's a weird behavior, right? They didn't have like a morning meeting like, all right, we're facing east today, facing east, all right? Break. There's like some physiological, natural reason why they do that. All right, let's look at the numerator. Y'all are like, is it too late to transfer out of this class, right? 2y squared plus y minus 3, that's the numerator. Hey, nothing divides out. But again, 2 is prime, hey, and so is 3. So I'll set up my little template here. It's going to be a 2y and a y. I will. I'm going to come back to that. Thank you very much. Oh, maybe that's Aiden. All right. So factors of 3, maybe it's going to be a 3 and a 1, maybe. Well, are you okay? Yeah. Okay, good. So now let's just look at the middle term. We're looking for a plus 1. So I need a 3y minus 2y. So this has to be a plus like that. Now, yes, notice what I did here. I was talking. I wrote stay. I put change. I changed division to multiplication. But what have I really not done yet? Flipped. That's called a careless mistake. I obviously know the stay, change, flip rule, right? I obviously do. I mean, I was like trying to make a joke out of it about my dog, right? Who is actually a girl, not a guy. And she is a terror. She had muddy feet last night in the carpets. That's another thing. And I forgot to flip. Careless mistakes happen when you break your concentration. Okay? So it's always good before you walk away from a situation to see if it makes sense. Okay? I could either bring that to the bottom, because now I'm flipping, or change that back to a vision. So that also happens when you try to do too many things in one step. I looked around and I saw a lot of y'all just rewrote it, stay, change, flip without factoring. That's good, because all you're focusing on that step is stay, change, flip. When you try to factor and stay, change, flip, that's a lot to remember. And again, I have a stupid husband brain, right? If my wife were here, she would have caught that as soon as I made the first parenthesis. She'd be like, "You're doing it wrong." And I'm like, "Yes, dear." Right? Which, by the way, guys, you always do get the last word in the argument. Always. And it's, "Yes, dear." Keep that in mind. All right. Now, in the top, I'm going to factor this fella, and it's an easy one. Y and Y, and then -6. Ooh, this one's interesting, because -6 to get a 5, it could be a 6-1 combo, right? Because 6 minus 1 is 5. Or it could be a 2-3 combo, because 2 plus 3 is 5. So how do we know which one's which?
The signs.
The signs. Excellent. The signs. I need to get a negative product, so they have to be opposite signs. So that ends up being subtraction, yes? Subtraction. And I need to get a positive 5. So maybe it's +6 and -1. That gives me a 6 minus 1, which is 5. So the signs help you. That's the cows facing one way. Look for the signs. If the product is negative, they're going to be opposite signs, so it ends up being subtraction, okay?
Everything can divide out.
Right. And then you're also taking cues from elsewhere in the problem, right? Notice I've already done stay, change, flip with y'all's help. You brought me back to focus. But now the y plus 6s appear in the top and bottom, and the y minus 1s appear in the top and bottom. So now, because it's one big term, I still have it split into 2 separate distinct factors, but you could just as easily connect those 2 division bars, right? Everything is multiplied together. So now the fun part, right? You've like cooked the food, you've like set the table is set, right? You can smell the aroma of the math coming off the chalkboard. Chalkboard? What era am I living in? Can you smell it? And now it's time to feast. It's time to eat. This is the fun part. Ready? Let's eat. What happens? Those divide out. More, please. That's from the movie Oliver Twist, the musical. Very great show if you haven't seen it. And then more, please. Look at that. Things divide out from high and low. Oh, I like the highlighter swipe. That's excellent. I tell you not to obliterate it because I need to be able to see it. I never thought about doing it with a highlighter. See, I learned something today. You do it with the highlighter as well. That's awesome. Because really with this many factors, you really want to take inventory, and I want to be able to see what you're doing. With my line, I can still see things underneath there. So, no. I was going to say, let's take Brady out and teach him a lesson. Right? In the hall, Brady. Everyone.
What are you going to do? Dump me in the trash can?
Well, things don't cancel out. They do what?
Divide out.
They divide out. Because things divide out to give us 1. Things cancel out to give us 0. We are driving the bandwagon that is math excellence. We're doing it the right way. We're going to use the right terminology. 2y plus 3 also divides out. Yes, yes. And so what are we left with? 1. Wow. Is that anticlimactic?
Yes.
I don't know. Depends what you're expecting, right? that entire expression up there, for values that don't make the denominator 0, right? There are certain values of y that when we plug in give us 0 in the bottom. So the domain is not all real numbers. But any number that we do plug in that works, it's going to give us 1. Always going to give us 1. So we call that an identity. Yeah.
If you did state change flip in like the first step, couldn't you combine like terms and then just have?
Well, you couldn't do combine like terms because when you do state change flip and everything's still expanded, you would still have 4y squared minus 9 times the quantity y squared plus 5y minus 6. It would still be parentheses between those two, not plus signs. Okay? That's a good question. I didn't even think about that. Does everyone see what he's asking? All right. Yeah, it would still be a factor. So you couldn't combine like terms. So we call this an identity. The top part is always a 1. They're interchangeable. Mathematically, they are the same to us. When we have our pep rally on Friday and I'm out there cheering and we're talking about the unicorns and I say, we're number 1, we're number 1. And y'all are all in the stands going, that's right, we are. And then I say, okay, now we're going to change the chant. You ready? We're number 4y squared minus 9 over 2y squared plus 9y minus 18 divided by 2y squared plus y minus 3 over y squared plus 5y minus 6. We are. And y'all are all going to be like, whoa, look out, Canyon Cougars.
I don't think that works as well as we are number 1.
I don't know. Math at a pep rally would either get people really excited or flooding towards the doors. Like, we're in the wrong place. We're in the wrong place. Yeah. But my point is this is a mathematical synonym. Okay? Mathematical synonym. You could do it. You could do it. Hey, maybe not at a prep rally chant, but if you play a sport and your jersey number is 1, try putting this on the back and see if Reno can announce it, right? Texas Tubes.
I wonder what an announcer would think of.
Yeah, I don't know. You could. You could, right? Because they're synonymous. All right. State change flip. State change flip. All right. Now, any questions on A? Like reasonable questions. Okay. Now, this one was a quotient of 2 rational functions. It was one fraction divided by another fraction. The only thing is, it was written side by side. Okay? A lot of the times, we don't have fractions that are divided written like that. We have them written like this. This is essentially the same thing. This is a single fraction divided by another fraction. But notice, instead of the obelisk, or I forgot what the symbol is called, we have this horizontal division bar. Okay? And then this is where the division symbol comes from, right? It looks like that. It's something divided by something. When it's written like this, we call this version a complex fraction. Okay? And you can clean up a complex fraction in much the same way that we just did. But it doesn't always work. State change flip doesn't always work. Just ask my dog Winnie, who doesn't do the trick that I taught Ruby. Ruby's a boxer. She wants to please. My Boston Terrier, Winnie, doesn't do the trick. She's more like a cat. She's like, I ain't doing that. Okay? I ain't doing that. So sometimes the trick of state change flip doesn't work. So we need a better method. It will work in this case, but not in the next case. So let's develop another way to eradicate complex fractions that works every time. Let's get both of my dogs on board, right? They both like pepperoni sausage things, you know, you put on the pizza. That's their favorite treat. They'll do all kinds of stuff for that. Paint the house, yes, sir. Right? Well, that'd be cool if you can get the dogs to do housework. We're going to use this method, LCM over LCM. I call this the lick'em over lick'em method. Lick'em over lick'em. LCM over LCM. The lick'em over lick'em method. And we are doing this right now, I kid you not, in calculus. What you're going to do is you're going to look at the least common multiple of what I call your miniature denominators, your cute denominators. That's the ones that I highlighted. Okay, the big denominator is the entire thing below the blue line, x over x squared plus 2x plus 1. That's the big denominator. But in the numerator, we have a little denominator, and in the denominator, we have its own little denominator. So in order to figure out the LCM, where m stands for multiple, we need to do what with this expression? Factor it. Yeah. So I'm not going to do state change flip here. Even though it works, I want to teach you another method. This might be the last thing we do today. I get x cubed over x plus 1. All over, make that line a little bit longer. It's the main division bar. X over, and now to factor the bottom, it's x plus 1 times x plus 1, or x plus 1 squared. Now, the other thing that I'm going to do is I'm going to put parentheses around this x plus 1 up here. Even though I don't need to, I want to group it together as a factor. Okay? So again, avoid the temptation to do state change flip, because you need to be able to figure out what the LCM of polynomials are. What is the least common multiple between x plus 1 and x plus 1 squared? Not x plus 1. X plus 1 would be their greatest common factor, GCF. The least common multiple is the smallest factor group that both of them go into. It would be x plus 1 squared, right? It would be x plus 1 times x plus 1. So here's how you find the LCM. You need at least one of each factor type. So we need at least one x plus 1. And then you take the largest representative exponent on that factor. This is really x plus 1 squared, okay? You take at least one of each factor, and then you take the highest representative exponent. So the LCM, in this case, is x plus 1 squared. Now, here's the last thing that we do for the day. Extend out that main division bar and multiply by x plus 1. I'm going to put times x plus 1. I like it better that way, over x plus 1 times x plus 1. Now, notice I left a little room up there. You're going to think of this as an upstairs-downstairs problem. And tomorrow, I'm going to show you how quickly and efficiently eradicating complex fractions can be when you use the lick 'em over lick 'em method. In fact, complex fractions don't have a chance because you're going to be licking them over licking them, right? Just like we're going to do the Canyon Cougars, right? We're going to lick them over lick them. That's gross. All right. Y'all have a fantastic rest of your day. I guess you're off to a decent start.